Hello, everyone, and welcome. My name is Jessica Williams, Programs and Community Partnerships Manager at Chabot Space and Science Center. And thank you all for tuning in. We're so thrilled to bring you another exciting program live this evening, right from your living room. Tonight we have with us Faride Khalaf, who will be talking with us about the Jewel in the Sky, the International Space Station. Hi, Faride. I think you're muted, Faride. But first, I'd like to give a special shout out to the Chabot members, donors, and volunteers out there. You can join our community of science supporters by becoming a member at Chabot Space and Science Center. Through December 31st, when you buy a membership, Chabot will give a membership to a local teacher. Click in the link in the description to learn more. Before we get started, please consider making a donation to help us make these programs accessible and possible. These free events are fueled by you, our community, and thanks to you, we have been able to offer more than 75 free STEM events since April. Right now, we need your help to create STEM learning opportunities for our community at home. In less than a minute, you can make a difference by donating on Facebook here, there's a donate button, or at chabotSpace.org. We have a lot of upcoming programs coming up and a virtual balloon drop celebration at the end of the year. So be sure to join us for that as we celebrate the new year. And now I'd like to introduce Faride. Hi again.
Hi, everyone. Good evening. Thanks for joining us on this presentation about the International Space Station. And I guess we're ready to begin. So let's
let me tell folks who you are real quick. I'm going to read your bio if that's okay with you.
Sure.
So Faride is a retired career aviator with a passion for all things mechanical, and his lifelong love of science has driven him to studying and sharing the history of space exploration. And he was an airplane pilot and also a longtime volunteer at Chabot Space and Science Center. And you would give these talks about the ISS to the visitors at the center. Is that right?
Yes, I used to do that a few years back before I moved to the Central Coast.
Well, it's so great to have you here with us again tonight. You're a longtime member of the Chabot family, and we're looking forward to hearing the rest of your talk. So take it away.
Thank you. Let's go ahead and, can everyone see this?
Looks good.
Forgot to, this is what happens when you forget to rewind. Remember VHS rewind days? Okay. Okay, are you with me, everyone? Okay, good. Let's go ahead and start. There's our ISS flying across the sky, and this is what it actually looks like if you were to approach it with another spacecraft from a slightly higher orbit, because you can see Earth beneath. So on July of 1975, at 12:20 Universal Time, Greenwich Mean Time, the Russians launched a rocket. This was in the peak of the Cold War, and they were at the time our geopolitical adversaries, and we had all kinds of weapons aimed at each other. And this rocket that's lifting off in the picture was derived from the R-7 intercontinental ballistic missile, which the Russians were the first to build such a massive rocket because they had very heavy atomic weapons. We had miniaturized ours, so we didn't need to build something so huge to lift a heavy payload. But they had the advantage of the ability to lift heavy payloads from their weapons design. So there's your Soyuz rocket that's almost identical to that intercontinental ballistic missile. So what we did hours later on that same day, we had to respond, of course. Well, this was not an international crisis. If you notice, the rocket on the left is ours, the USA. That's built specifically for human spaceflight exploration. And it's the Saturn 1B that you're looking at. There was a Saturn 1 and also a Saturn 5 for the moon rocket, which was the heaviest rocket ever to lift off of Earth. And that record will be broken by the Space Launch System when it's online, hopefully soon. So this was a different event. This was not something dangerous about to happen. In the peak of our Cold War, our scientists and our engineers on both sides decided to do something good for humanity. And, you know, let's take these two adversaries and have them go up and have a good time getting to know each other and accomplishing a huge feat to build two different spacecraft from very different countries with different technologies and work together to design an adapter so that they can dock these two in space together. Now, if you look at the crew of this Apollo Soyuz test project, as it was called, but at the time, the media used to refer to it as Union in Space. And the post office issued stamps about this program as well. Now, you can see that they have a mission patch. They're all wearing the same mission patch. Notice how they wear theirs on the Russian side. It's literally upside down compared to ours. Well, we put Apollo first, and they put Soyuz first. And there's your national pride. And that's about the depth of it. The rest of it was all hugs and sharing time in orbit. So that's what it looked like in the final moments of docking. And we had a considerably larger spacecraft. The capsule was designed to go to the moon and carry provisions for around 10 days or so if you had an emergency and needed to stay out there longer. The Soyuz was not designed to go to the moon. So a much smaller spacecraft. They took, instead of 3 cosmonauts, they took 2 cosmonauts and additional fuel and provisions for this program, for this mission. And this is the exact moment when the 2 commanders, Tom Stafford and Alexei Leonov, met right in the middle when they opened the hatch to the Soyuz. And this is a moment, there's no up and down. I could flip this picture and it would be the same as, like the mission patch. It depends on your perspective. And that's Deke Slayton on the American side, embracing in a head-to-head manner. And what's nice about this picture is they don't have to be acrobats. Deke's not bearing the weight of Alexei on his shoulder or anything like that. So you can pretend to be a gymnast in space, real easy to do when there's no gravity to work against you. So Alexei was the first man to walk in space. And we responded when Ed White went up on Gemini 3, or I think it was Gemini 3 or 4, with Commander Jim McDivitt, and he did his spacewalk. But they got the first one for the record. Okay. And in this moment, you see Tom Stafford, because he's the commander of that spacecraft, the US Apollo spacecraft, and Alexei Leonov. Also, Alexei Leonov was slated to be their version of our Neil Armstrong. They were going to beat us to the moon. That was their goal. And of course, we were first to arrive at the moon. And Alexei and his friends, one of which is a Soviet cosmonaut that I met, hero of Russia, who set many records in space himself, Georgy Grechko. I saw him at the California Academy of Sciences like 2 decades ago or more. And he told me the story how he and Alexei and a bunch of cosmonauts were watching on TV. And as soon as Armstrong stepped on the moon and said, one small step for man, one giant leap for mankind, they got up and left and went to a pub and got sloshed because they were sad that they didn't win that race. Now, many years later, more recently, we did something like we did in 1975. We decided, let's do this again, except let's build a huge laboratory that orbits the Earth. And if we do this together, we can build it bigger. We could contribute financially to this huge expense. And we can also get other countries to contribute and benefit from this joint venture, truly an international space station. There are European countries involved, and Japan is involved. China is not part of the ISS. They want to do things on their own. And as long as they do it with their own technology, we're happy with that. But they get a lot of help from the Russians, so they're really using technology that's been around. It's not like what we're doing. Gosh, SpaceX it's blown my mind, and I've been in aerospace pretty much all my life. And I did take a tour of their factory. You can eat off the floor. It's just phenomenal. That's another story for another time. This is the crew of the space shuttle mission number 88. In fact, we carried a Russian with us, and there he is sitting there. He was at the time, or later on, he's got white hair now, by the way. I can't remember his name. At one time, I could name just about every cosmonaut and astronaut, but I've been away from that for a while. On this mission, he shortly after this mission, he became their equivalent of our NASA administrator. So he became the head of the Russian space program. And you can see these two guys were dressed up as technicians to go outside and assemble these two first pieces of the ISS together. So those first two pieces, one was American right there. And actually, no, the American one's here. It was resting in the cargo bay of the space shuttle. So using this remote manipulator arm, also known as Canadarm1, they were able to lift this out and stack it on top of the pressurized adapter behind the crew cabin of the space shuttle. And that way, in this unpressurized, exposed to space cargo bay, you don't have to have people out there, dealing with this. They can come out of the space shuttle crew cabin and go through this adapter directly into this piece called Unity. We built that here in the US, and the piece that we grappled up in the sky and brought slowly down and set it on top. And then those two astronauts, the Americans, went outside with their tools and secured all the permanent fasteners that were required to make a solid connection that's semi-permanent. And there is the very beginning, the genesis of the ISS. Not much to it, just two big beer cans, essentially, with a lot of insulation and equipment inside, with more exotic alloys than what you use to make beer cans and things. But anyway, these two jewels built in two different parts of the world by two different cultures and economies to the same specifications so that they're compatible and they can work together. For example, the electricity has to be standard.
Well, it looks like we froze for a moment. Let's see if we can get Faride back on with us. Hang tight for just a moment. All right. Well, Faride looks like maybe lost service. So if you don't mind just hanging tight, he'll come back onto the call and we'll continue the talk. Sometimes this is how it goes with online using our Wi-Fi. So thank you all for your patience and hang tight, and we will wait and see if Faride joins us. And thank you so much for your patience while we work out our technical difficulties. Hang on and let's see if he comes back. Thank you, everyone. All right, looks like we got you back.
Yeah,
No worries, all good. We're still here. We still have everyone here.
I
So
got lost in space, people. Sorry.
we got lost in space. All right, I'll let you continue. No worries. We're all
Yeah, it
set.
happens with me sometimes. How
That's what
fun.
I said. Sometimes we have these technical difficulties are out of our control. So glad you made it back.
Yeah. Okay, so here we are. Did you all see the Lego pieces?
Maybe we could start there again.
Okay. Thanks, Jessica. All right, we're back. Sorry about that, folks. I hope it doesn't happen again. Um, so, like Legos, we took individual pieces, in this case, large habitable compartments and laboratories and experiment packages and all kinds of stuff, plus life support gear, solar panels, truss bars, truss segments. Basically, the truss segments are the backbone that keeps everything together on a frame, so that when you go to accelerate the space station, in other words, push it with some rocket thrust to put it in a higher orbit, because over time the orbit decays due to the thin atmospheric drag up there. So here we are, and Zarya, which means in Russian it means
Sorry, Faride, do you mind sharing your screen again?
Oh, I didn't do that. I have to share screens. Oops. Share. Okay. So we can see the screen now?
Yeah, we just need to see the full screen.
Right. Go in there now. Here we are.
There we go. Perfect.
Okay, so we were talking about Legos. We all know what Legos look like. There's Zarya, which means sunrise, which is an appropriate name because it implies the dawn of a new space age where we're working together as a species, not just us Russians and Americans. Us Russians, us Americans and the Russians. I don't speak Russian. And I'm not from Russia, never been. Someday maybe I'll visit. I hope to. Zarya was the very first piece. Think of it as that grain of sand that gets into an oyster and irritates the oyster. So what does the oyster do? It builds around it. Well, like an oyster, humanity built this whole contraption that you see in space around that one module. So we sent up one to mate to it, called Unity. Now, there's your pearl oyster. I call it a jewel in the sky because it is a jewel. It's beautiful. It's more expensive than any jewelry you could wear on our planet because the cost of going to space is extremely high. There's a lot of fuel and manufacturing. Just getting that many people to agree on how to do something, I don't know how they do it. It's amazing. The people skills are definitely a major ingredient to accomplishing these. So if you don't think you need to learn English, for example, in school, because you're so good at math, you're so good at physics, but if you can't communicate because you can't project your voice or just aren't comfortable discussing things with a large group of people, then that's going to be an issue. And people work on that. They have classes for that. And I'm telling this to young people who might want to do some of this great stuff in the future. Okay. So as of March of 2011, this is pretty much a completed project. All of its solar panels are installed and most of the heavy equipment was delivered, a lot of it by the space shuttle. So we took advantage of the space shuttle program to do so much that was difficult to do with other rockets. Because you can send equipment, the cargo, and the crew on the same launch. So it makes for a really good way to approach this building project. Now, this is a logarithmic scale, meaning that if you wanted to show the true altitude spacing, it would probably be about 15 feet tall and it wouldn't fit on your computer screen. So the ISS resides way up here in the very top of the atmosphere, what we call thermosphere. Thermo because it's super hot. This line represents the temperature. And you know what? There's not enough heat outside the space station in the shade to cook a hot dog, but the temperature can approach thousands of degrees because temperature is defined in physics and in all science as not what you set your thermostat to in your room or in your house, but in actual definition, it's the average kinetic energy of the molecules in motion. So you're averaging molecules that are so spread out, there are very few. And if you average them and they're moving fast, yeah, but they're not really, there's not enough of them in density to cook anything. So you're not going to burn yourself there, but it's considered to be hot. So that's one of those scientific scratch your head kind of things when they teach you that in school. It doesn't make sense, but you really have to learn physics to really get a good grip on this stuff. Now, if you look at the right top corner of the picture, you can see all the kinds of crud that comes from space. These are the space hazards, all these charged particles. Those aren't forms of energy, that's mass. Those are little bullets of matter. Although they're the atomic and molecular size, some of them are bigger. A grain of sand in space can really obliterate a person if it impacts you at 17,000 miles per hour. So there are physical hazards, micrometeoroids, as we call them. And then you have radiation hazards. You have infrared, which is direct sunlight. It will cook you. Visible light is so bright. Now, infrared, the sun's heat reaches the Earth's surface all the way down. Unfortunately, climate change is really a huge component of it. It isn't just pollution, but Earth's retention of heat. If this heat, once reflected back into the sky, gets reflected back down again by the upper atmosphere that contains what they call greenhouse gases, then you're going to start building globally a temperature that's going to run away from you. And that's what you're trying to avoid. So folks, please take climate change seriously, and we're all going to be better off if we do that. Okay, so these guys, they're in a very, very harsh and hostile environment. Personally, I wouldn't want to live in space because I'm not going to live a very long life if I do, even with all the protection afforded to this crew. This is cumulative, so it's not good to be in space without additional protection. So when we do go to the moon and Mars, we're talking about subterranean habitation to protect us in the absence of an atmosphere. So yeah, going to Mars is going to be a real challenge. Fun. Okay, currently this astronaut, this is an American NASA astronaut named Shannon Walker, Dr. Shannon Walker. She has been up in space several times, has spent a lot of time up there on the ISS. She flew the space shuttle, and she is up there now. And this is what astronauts like to do in their what they call off-duty time. Cosmonauts share the same cupola, and they come out there. There is a guitar on board the space station. Often intellectuals also play music. And if you've noticed all these well-educated TV reporters that aren't working in their normal work environment, they're all working from home. You notice in the background, often you see a lot of guitars, and it's a really fun thing to do, learn a whole new language, music, and it's a skill and it's good for you. And so they do that up there. They play music, and they share meals, and it's quite a place. I couldn't get enough of that view. So when I started doing these presentations at Chabot years back, I started with the Expedition 29 with Commander Bob Burbank. There's his name on the bottom. He was the commander on board the space station. And here's a picture of Bob right here. And here's another American astronaut. I think he's up there right now. I don't want to say, but I used to be able to name every one of these. I think that's Ivan Isham, and this is Anton Shkaplerov, and that's it. I'll stop guessing. Okay, so now we're at mission 64 currently, which is kind of cool. So where in space are these guys hanging out? Well, these are all the man-made satellites we put up in space, and there are quite a few of them, and it's a beehive of them. Now you see a nice band of satellites that are at the same exact distance, kind of give Earth a Saturn-like ring appearance. Those are geostationary satellites, also known as geosynchronous satellites, at about 22,300 miles up in space. Anything placed in that orbit, in that circle, is going to orbit the Earth at the same rate that the Earth rotates. So, you know, these internet TV, what do you call them? Direct TV dishes or dish TV, aiming all at the same point in the sky. They're aiming at one of these little dots that the station signal is carried through. Now, in between, you have orbital periods varying and the missions varying. Weather satellites tend to be out in this area so they can cover more of the Earth's surface in a better picture. Also, everything in here that's real close, these are basically your GPS satellites and a lot of low Earth orbiting satellites. A lot of spy satellites. If you want to get a good look, you also want to get close to what you're looking at. So military satellites, things like that. So many of them are classified, we don't even know what they do. But NASA has a listing of all the satellites that are up there, and you can research some of it. When the internet was new, they were putting stuff on the internet that I thought, oh my God, I'm afraid to look at this. They're going to come, the men in black are going to be knocking on my door, and my friends and family will never see or hear from me again. It was too much information. Well, a lot of those sites are gone now, and no explanation why. So, but I remember some of them. Here it is again, a different picture of the ISS, and you can see how the sun hits that thing in its full force. The sun is unfiltered. It's not going through our atmosphere. So it carries quite a bit of punch energy-wise. These solar panels are the most expensive solar panels ever built to this day. And they're double-sided. They absorb from both sides because Earth is reflecting a lot of bright sunlight, and they pick up electricity from the Earth's reflection of sunlight as well. So they've really gone for maximum efficiency here. And these panels are also very thin and light because they have to go to space. And there's only one spare set that resides in Johnson Space Center, and I personally saw it, and it's the only replacement they have right now. So any damage over the life of the space station is likely to be permanent, because I think the space station is going to go out of service in another 4 or 5 years. Like 2025 is what Obama administration planned to fund this for. And that's good because we're learning a lot from it. Now, here's some typical workers out there. And I may have to cut this a little short just because I want to give you guys a chance to ask some questions. You can see that they're connected with these thin lanyards. Okay, that's so that if they slip, they don't disappear into space. They do have emergency thrusters, so they can actually fly themselves back using reaction jets, the same way any spacecraft maneuvers with a reaction motor. So they do have their tiny little propulsion system for emergencies. But it's best not to get detached in the first place, because if a panic should ensue, your performance will be diminished significantly. And, it's always a possibility. Panic is nothing you plan for. It can happen. So we don't want that. Now, I want to talk about some of the experiments, and I'm going to pick one of my favorite ones to describe to you. What are they doing up here in the space station? A lot. Don't think of it as a vehicle for space travel. That's not what the space station is. The space station is like a barge up there where we go to do some work. And why do we do it there? Because we are in an environment that's a near perfect vacuum. So we can do a lot of testing with, pressure vessels and stuff, leak checks. You want to make sure, if you want something not to leak, that it's been thoroughly tested and vetted. That's the kind of stuff they do up there on the outside mostly. The ISS should be thought of as a engineering project. It's where we're testing things like space toilets, better ovens, a way to grow food. I don't know if this has been done before, but I would be interested in knowing what it would be like to carry a child to term in space. That might not be something we're willing to attempt as an experiment. Maybe we're not ready for that yet. But if we're going to go to the stars, when we leave this planet, it won't be us that arrive at the stars. It will be several generations after us. So it's a big venture to expand into space. Now, what are they testing here? This is a project the Russians designed called Matrushka. And every slice is so that they can insert all kinds of sensors in this humanoid test article. And what they do is they put it in an area of the space station where there's very little protection from space particles, those high energy particles, gamma rays, X-rays, and so on. And so what they were doing, the Russians, we were doing it on our side with what we call the phantom torso. These things, if you try to read up on them now, so how's this experiment going? You're going to find that these are so obsolete right now. When I was boning up for this presentation, it was like hitting a brick wall. Like, oh my God, this is now old news, really old news. Imagine on the American side in the middle of the night and it's dark and you want to go use the facilities. And you literally are flying through the corridors of the spacecraft and you go through a bulkhead and you just notice this thing. Or can you imagine waking up next to that? It's like a horror film. But anyway, on the exterior here, you see some radiation detectors that detect what's coming in. Now, just because these are all on this side, you can tell this is the side they expect the radiation to approach from. So you would call this the radiant. And these are all the detectors, and then they have internal detectors, and they make a comparison to see how much of this flesh analog can absorb before it reaches vital organs. This is serious medical stuff. The Russians did one up on Matrushka. They were circulating fluids through here and see how much of this fluid, a special fluid, I don't know what the mix or the recipe was, but they can examine it through the circulatory system, like this analog for cardiovascular system, or rather, cardiovascular system. And they circulate this fluid and then they do their examination that way. On a later version of the Matrushka, they actually circulated blood and did some direct observations of how it affected blood cells. So this is some pretty cool stuff. These are the two Russians that are putting Matrushka together. You can see the fluid reservoir down here, and then they put a jacket with sensors on the exterior to look like a scary looking mummy that we have on the American side. By the way, our name for this, I think I may have mentioned it, is the phantom torso. Phantom torso. Keep it away from me. I'm gonna have bad dreams tonight. Anyway, this one looks a little more friendly. NASA, Johnson Space Center, and General Motors together worked on this project. And this is Robonaut 2 of the Robonaut series on board the ISS. So back to Bob Burbank, who is, by the way, Commander Burbank got all his flying credentials and education and experience through the Coast Guard. So I'm a volunteer in the Coast Guard Auxiliary, so I'm very proud that one of our Coast Guard people made it into space as a commander, not just arriving there, and he was a big deal. So here at Johnson Space Center, you see him shaking hands with Robonaut. And as planned, he did the real deal on February 16th of 2012. There's Robonaut. Now, Robonaut is basically a robot from above the waist, but it doesn't have legs. It's not like Lost in Space. You don't need legs when you're orbiting Earth because legs are for walking. You just float there. This thing basically could attach itself to the end of the Canadarm and do some of the tedious work or work that would be difficult to do by hand outside. And it's very capable of doing some intricate stuff. So this is really neat, and it can take the workload off the astronauts. Now, I want you to learn how to foretell a sighting of the ISS. You do need to know which way is north. So I'm going to leave it to you to find out. But if you don't have a compass and you're out in the woods and you need to find out which way north is, here's a trick. Here's the Big Dipper, and this is Cassiopeia. Big Dipper is visible at our latitude pretty much at night if the sky is not obscured by clouds or fog. And it's sometimes light pollution and a bright moon can make it difficult to find these objects in the sky. But this pattern, the Big Dipper, if you use these two stars called Merak and Dubi, those are Arabic names. The Arabs gave a lot of the names to the northern hemisphere night sky, the stars, because they were early observers and contributors to astronomy, not astrology, different. Anyway, Polaris simply means pole star, north celestial pole, or the North Star. So if you run a line directly through the South Pole, through the Earth center, and through North Pole, and keep going, it's going to hit the North Star. That's why it's called the North Star. Be careful not to mistake it for the brightest star in the sky. Everybody, if you ask them, a lot of people, do you know how to find the North Star? They say, it's that one, right? Why do you think it's that one? Well, it's the brightest. No, that's not how you tell the North Star. So you use Merak and Dubi, called the pointers, and you go straight to the brightest star that they point to. And you can also double check it against Cassiopeia, like that. Once you find the North Star, look straight down, and that's north. Here's the Little Dipper, the tail of the Little Dipper on the handle. In other cultures, some cultures in the Arab world, these are called Big Bear and Little Bear. So Little Bear's tip of his tail is also the North Star. That's another way to tell. And then once you can find North Star, left is west, right is east, directly behind you, of course, is south. And when you go to NASA's website and you sign up on Spot the Station, which is real easy to do and it's fun, you can select one of three methods to get notices of an upcoming traverse of the space station where you could see it in your location. So you enter your zip code, or you can go by latitude and longitude or by city. And you basically sign up for a year free of charge. Your tax dollars pay for NASA, and the best use of our tax dollars, and it's less than 1% of our budget. So if you enjoy, a lot of the here, you would not have these smartphones if it wasn't for the space race. So it gave us a lot of great technology and modern conveniences. So here's what a space station looks like at night. If you expose the shutter, if you have the shutter open for several minutes, you can see it gets real bright over here, then it gets darker as it goes by. And here you can see whatever camping light that was used was overexposing the frame. Here's another picture. Now in this picture, you see the space station flying a curved path. That's an optical illusion from the lens. They're using some kind of a wide angle lens here. This traverse can take up to 6 or 7 minutes. And it's at its brightest here. And it appears out of nowhere. And it seems to get fainter and disappears. It's just that here, at its brightest point. It's reflecting the most amount of sunlight back at us. It's not electrically lit. There's no need for lighting on the outside. So what you see is purely reflected sunlight, the same as you would from the lunar surface looking at a full moon. And at the moment it disappears, it's passing into Earth's shadow. At that moment, the station crew, or if they're looking, they would be seeing an orbital sunset, okay? And since they can't see the sun's not shining on them, they're still there. They can see the Earth. We can't see them because they're not illuminated, and they're 250 miles away. This is a great picture because it shows two straight lines. The ISS is an object in motion that's not under any kind of propulsion system. It's just coasting around, and it's not moving at a constant velocity because it's constantly changing its direction. It's not flying in a straight line. Earth's gravity holds it into a circular orbit, right? But for us to see it, we would always see it traveling at a straight line. The only way it would be moving in a different direction is if it's not the space station. So if it changes direction, it's an airliner, okay? And now if you look at this series of dotted picture, a line here, that's a jetliner's wingtip straws doing double flashes as it goes across the sky. And for the same amount of time it took for the stars to be displaced in the sky as the Earth rotates, it took the space station the same amount of time to move across the sky. So it's moving against the background stars pretty fast. That's another way to tell. It's moving at 17,500 miles per hour, and it takes 90 minutes to go around for you to see it again. Sometimes you can see it twice on the same night, and that's fun. To think that you just saw something an hour and a half ago and there it is again. We used to do that at Chabot. If it were possible, I would always make an announcement that you can see it twice. This little streak here is a meteor. It's not even going in the same direction as the Earth rotation gives us the appearance of the sky to move. So there's definitely a meteor right there. It burned out quick, it comes in, gets bright, and poof, it's gone. So there's a lot you can tell from this picture. It's one of my favorites. I like that tree standing out there. Now, here's a picture of the space station taken with an earthbound telescope that's capable of tracking this space station in low Earth orbit. And there's a space shuttle approaching to dock. A different telescope at a different time taking a picture gave us more magnification of the same event. Not the same exact event, similar, different times. And here's a size comparison to a Boeing 747. You can look up all this stuff. You Google these pictures. It's all on the internet. And everything you get from NASA is free for you to use. They have some great ultra HD, ultra high definition tours of the space station. I recommend you go take a look at these. You can learn a lot from them. Here's some other comparisons. Statue of Liberty. Statue of Liberty is not really a tall object. It's not like the Empire State Building. But here's the Wagon Wheel Space Station from 2001, A Space Odyssey. This is fiction. It was never built, but 0G would be in the middle, and people being flinged around would experience a 1G environment. So it would be a more habitable place. You don't need to have additional exercise if you're on that station. There's the Titanic. Moving on, look in this portion of the picture. That's not a sunspot. Right there, let's blow that up. There it is. Space shuttle catching up to the space station. Early construction because of the total of 16 ribbons of solar panels. You have only 4 of them installed. So this is early in its evolution. Pretty cool though. It takes less than a second for the sun, for this thing to pass across the sun. So you got to be quick to take a picture like that. So we're getting close to the end. Here's what the space station is. Basically, it's a ship in the sky, and the sails to me represent the solar panels. And you got crew on every ship, and they have work to do, especially if it's a NOAA, National Oceanic and Atmospheric Administration ship, or a Greenpeace ship, or a science vessel, or maritime operation. There's a lot of commercial activities that go uh, on the space station as well. So these guys are up there on their ship doing their jobs. So I see 1, 2, 3, 4, 5, 6 full moons up in the sky doing work. Think of these guys as astronauts and cosmonauts up on that space station. And this guy's like mission control, passing information to them on what to do. Now, on old sailing ships, pirate ships, if you don't follow orders, you get punished. You walk the plank, get keel hauled, or something, if not lethal, painful, certainly. Hey, there's a yard arm or a mast or a boom on a sail, and they're up there doing their job. These are like sailors laboring in space doing this. These are little comparisons I like to make. And mission control down here, Capcom, capsule communication, everything they need to hear goes through one voice. It's usually an astronaut and a friend. So there's no miscommunication or tension. You know each other well, and it makes for a less stressful work progress. So that's why they use the capsule communications person, and they always speak in a soft tone and keep things cool. They give them what they need, and they read checklists often. You don't want a highly paid astronaut on space station time reading a checklist to these guys outside when someone on the ground can do it. So a lot of the work up there is being done on the ground. It's a huge team effort. Now, if you disobey capsule communications, you're not going to get keel hauled, but you'll get a timeout. That's how we do things now. And this is what a timeout looks like. You just sit him up and put him out there until he's willing to do his job when he's told to. I can't hear the roar of laughter, so I'm assuming you're all just laughing really hard at that. But no, this is just an adapter for a work stand. And you put an astronaut at the end of it, and you take him around like a mobile ladder or a cherry picker. It's pretty cool, huh? Now, this is another analog comparison. Think of the space station as this log. Okay, we didn't set it into motion using rockets. We did something different. We let gravity propel this thing down a hillside. And instead of astronauts and cosmonauts with PhDs and so on, and I don't even know where this picture is from, what country it is, and I'm not making fun of anybody here. I think it's pretty cool. I would go to watch that. I certainly wouldn't want to ride the log, but think of the excitement of watching these guys take a big risk riding this thing down a hill. I mean, that's how I see myself. I see myself as a witness of something spectacular going on in our skies with this thing we threw up there and send a bunch of people to go round and round and do a bunch of productive work. Now, this is my last slide, and I commemorate this last slide to the first rendezvous in history of manned spaceflight. And that credit goes to the Americans on the Gemini missions 6 and 7. You may recognize some of these names from 1965, December 15th. This is before we even went to the moon. This was just leading up to it. Frank Borman, the commander of 7, with Jim Lovell. Jim Lovell was second in command. He later on had command of his own spacecraft, and that was Apollo 13, which was known as a successful failure. So there's a little history there. Here, Wally Schirra was commander. He was one of the original 7 Mercury astronauts, And he took Tom Stafford with him. That name should be familiar because he was on Union in Space. So everyone who was in the co-pilot seat ultimately became the captain of a mission later on that did more and did greater things for humanity. So with that, my presentation's finished. I do recommend you go to NASA's website and do a lot of digging in there. You're going to find so much, and it's a lot of good stuff to learn. If you're interested in becoming a scientist or an engineer, you're never going to get bored. So with that, I'm ready to take some questions. I hope you enjoyed it.
Thank you. That was such a fascinating talk. It's really interesting information. Exciting that we're still up there today, and that there's astronauts who are there at this moment. We did have some questions that came in, so we have time for a few. One of the questions that came in was, is there a high risk of radiation even when you're inside, for humans, when you're inside the ISS?
Yes, it's higher than what you would experience in Earth orbit, but astronauts keep track of their radiation exposure, just like radiologists do, and X-ray technicians and hazmat people that clean up after places like Chernobyl, 3 Mile Island, where you're in a high radiation environment, Navy submarines that are nuclear powered, and so on. You're gonna receive radiation and hopefully information on how to not die from it. And so it's a cumulative effect on your body, and they wear film badges that records the radiation, just like the equipment they had on Matryoshka and Phantom torso. But this is to keep track of your career limit for radiation. For example, the first astronauts to come back from Mars will probably not get another trip to Mars because it would put them over the top. It would not be good for their health. So that's a one-time deal. Get in, get out, and let someone else go there and take the chance. So even airline pilots receive radiation. The ones who flew Concorde received more because they had less atmosphere above them, cruising at 60,000 feet. So the flight crew of the Concorde were vulnerable to space radiation. And all the world's telescopes, when Concorde was regularly flying scheduled flights, had to immediately let the crew of the Concorde that are in the sky know by radio when there was a coronal mass ejection or a solar flare, which can emit X-rays. And we can observe events on the sun's surface that gives us a little bit of a lead time. And for the dangerous particles to arrive, because they're not traveling at the speed of light, there's time for them to drop to a lower altitude. So they would come down and fly with the slowpokes that we normally can afford to fly in for the duration of that hazard. So yes, radiation is an issue.
Okay, so we have another question. How can I tell the ISS apart from any other objects in the sky? And is it possible to see the solar panels?
The solar panels, I've tried it with binoculars, 10 by 25. So that would be 25 magnification. No, 10 magnification, 25. No, 50, 10 by 50 millimeter objective lens. That's the big lens on the sky end of the binoculars. You can't see those solar panels. Think about it. You saw it over a football field. If you could see a football field from 250 nautical miles away, then yeah, but your eyes can't see that. I don't even think an eagle's eyes can see that. But if you have a good telescope, any of our telescopes at Chabot could do it if they could move fast enough to keep up with the space station, because it's moving faster than anything in the sky. It doesn't stay above our horizon for more than 10 minutes. And it comes back around 90 minutes later, where you have to wait 24 hours for the Earth to rotate that fast. So our telescopes move with Earth rotation, Most telescopes do. So the people who take those pictures, they're the techies and nerds that you see YouTube guys with their 3D printers building all kinds of cool gadgets and stuff. These are guys that like to tinker. They're smart, and they can make their telescopes do a little extra, and that's how we get those pictures. Yeah, did I answer that question right?
That was good. That was a two-parter. So how can you tell
the main part, the main part is the ISS reflects sunlight. It moves faster than anything that's beyond the Earth's atmosphere that we can see, because it's so big and it reflects a lot of sunlight. We can see other satellites too, but they're fainter. It's the third largest object in the sky, third brightest, excuse me, not largest, third brightest. It's after the moon. It's sun, moon, and then the ISS, which after 2025, we may never in history be able to observe something, a spectacle like it. It does not have any colored lights on it. If there's a blinking light, it's an aircraft. If it changes direction, it's an aircraft. And if it arrives before its scheduled time, it's an aircraft. It's not the station. The station's always on time. It's like clockwork. So that's how you can tell.
That was another question, actually. Can you see the ISS at the same location each night, even if it's twice in a night?
No, because the ISS in space orbits exactly in the same orientation. So from where they come around at the same time each day, looking away from the Earth, they would see the same star patterns at the same time seasonally, because the Earth's also going around the sun. So we're going to be subject to seasonal changes. So the astronauts and cosmonauts that are there for several months will see the seasonal changes. But from each night to the next, no. What you see that's going to be different is the Earth's rotating. We're seeing different parts of the sky. We're not lined up with the ISS's orbital plane. So inside the ISS's orbital plane, we're also rotating at a different speed. So that's why you won't see it that way. And it takes computers to figure out when and where to see it. So when you sign up for NASA's Spot the Station, and you get yourself a nice little text or an email or a phone call message, whatever, you can choose your method. I use texts, and it pings, and I say, hey, in the next 3 hours, we can do that. Here's something you can do, parents with their children or brothers, twins, sisters, anybody who's within a few 100-mile radius of each other. You can look up at the sky at the same time and see the same thing at the same time, right? Because, we won't see each other because of the Earth's curvature, but we can both see something that's 250 miles high in the sky at the same time. And it's kind of a neat way to bond with someone special, I think.
That's really cool.
Yeah.
I think we have time for one more question.
Sure.
So what can we do to see other Earth orbiting satellites?
Oh, that's fun. When I go camping, my friends are always hiking, and I don't hike. I don't drive 3 hours to go to the mountains so I can get exercise. No, I go there and take advantage of the environment that I rarely see and I don't see enough of. So one of the best things about going to the mountains, away from city lights, is that you can see the stars. They appear brighter, the air is smoother, cleaner, and so on, less pollution, and less light pollution as well. So you get better sky viewing, and fainter objects become much easier to see. Near sunrise and near sunset, in the twilight hours, are when you see the most satellites, because they're not passing into Earth's shadow. They're visible because satellites, like the space station, just reflect sunlight. So I would say anytime after sunset. In fact, we used to have a star party with my friends in Denver every year. Whoever could spot the first artificial satellite gets $1. So I won it one year. I got $1. So there.
Well, thank you so much,
Oh,
Faride,
you're
for
welcome.
this Wonderful talk. I learned so much tonight, and I hope that everyone else learned a lot as well. It was really great. I did put the link to the station link website in the chat, so folks, hopefully you can go and check out when you can see the space station overhead. And we really enjoyed having you today, Faride. So thank you so much.
You're welcome. I enjoyed doing this. And remember, NASA works for you, and everything they discover belongs to us. We pay for it, we reap the benefits. So copyright laws and things like that don't get in your way. NASA does say, if you're going to use our pictures, just give us credit for it. And you can use them any way you want. And that's how I get to use them in my presentations. It's a gift from my government, and it's a dividend on my tax money. So it's there for you. Enjoy it.
That's wonderful.
Yeah.
Well, thank you again for joining us, and thank you all for joining us tonight. And we hope that you'll join us again tomorrow night at 9 p.m. for our virtual telescope viewing with our resident astronomers. And they're on every Saturday night at 9 o'clock. Weather permitting, they're either able to look at what's in the sky, or they'll show us some remarkable pictures that are taken with our telescopes. And also, this coming Tuesday, December 8th, we have a talk in partnership with the SETI Institute about remarkable exoplanets, and the speaker will be Dr. Frank Marchese. So please be sure to tune in for that on Tuesday, December 8th. And for notifications about our events and more fun science content, like Chabot Space and Science Center on Facebook, and visit our website at chabotspace.org. Thank you to everyone who tuned in tonight, and a special thanks to our members, donors, and partners for helping us bring science to life for everyone at home. Before you head out, please consider donating to help keep these programs free and fun for everyone. Right now, we need your help to create STEM learning opportunities for our community at home. If you would like to support Chabot Space and Science Center, you can make a donation here on Facebook or at chabotspace.org. Thank you all for tuning in with us tonight, and we hope to see you all again soon. Have a good evening, everyone.